Whenever we need to store multiple values in Java, we usually have two popular choices, Array and ArrayList. At first glance, they look very similar. Both store multiple values, both support index-based access, and both are used everywhere in Java. So why does Java have both? Should you always use ArrayList? Or are arrays still useful in modern Spring Boot applications? By the end of this video, you'll know exactly when to use each one, understand how they work internally, and confidently answer array versus ArrayList interview questions. Let's get started. Let's start with arrays. An array is the simplest data structure available in Java. The first thing to remember is that an array has a fixed size. Once you create it, the number of elements cannot increase or decrease. Every element belongs to the same data type. Another important characteristic is indexing. The first element starts from index 0, making element access extremely fast. Arrays can store both primitive values like int, double and char, as well as object references. But theory alone isn't enough. Let's verify this in IntelliJ. Alright, let's understand arrays with a simple example. I'll start by creating an integer array that stores three values, 10, 20, and 30. Now, we can access these elements using their index positions. The most important thing to remember is that arrays always start from index 0, not index 1. Here, you can see I'm accessing each value in the log statements using its index. Let's run the program and verify the output. Perfect. As expected, we're getting all three values. Now let's try something interesting. I'm going to assign a value at index 3. Before we run the program, think about it for a second. Our array contains only three elements, so the valid indexes are 0, 1, and 2. Do you think Java will automatically increase the size of the array? Let's find out by running the program. And there it is. Array index out of bounds exception. This exception occurs because index 3 doesn't exist. Unlike ArrayList, arrays never grow automatically. Once an array is created, its size remains fixed throughout its lifetime. And that's the biggest limitation of arrays. So the obvious question is, what if we don't know in advance how many elements we'll need? That's exactly the problem ArrayList was designed to solve. Let's understand that next. ArrayList solves the biggest limitation of arrays. Instead of fixing the size in advance, it grows automatically whenever required. It also provides many useful methods like add, remove, contains, and size. One important interview point. ArrayList is not based on linked list. Internally it is backed by an array. Let's verify that in IntelliJ. Now let's see how ArrayList solves the biggest limitation of arrays. I'll start by creating an empty ArrayList of integers. Unlike arrays, notice that I haven't specified any size while creating it. That's because an ArrayList grows dynamically as we add new elements. Now let's add a few values, 10, 20, and 30. I'll also print the size of the ArrayList along with all its elements. Let's run the application. Perfect. The size is 3, and we can see all three elements in the output. Unlike arrays, we didn't have to decide the size beforehand. We simply kept adding elements, and the ArrayList handled everything for us. Now let's remove one element. Here I'm removing the element at index 1, which is the value 20. Let's execute the program again. Notice the output. The value 20 has been removed successfully, and the remaining elements are 10 and 30. With arrays, removing an element usually requires shifting values manually or creating a new array. ArrayList provides this functionality through built-in methods, making our code much simpler and easier to maintain. Now let's add a couple of more elements. I'll add 50 and 100. Notice that I'm still not worrying about the size of the collection. Let's run the program one more time. Perfect. The new elements have been added successfully, and the array list has grown automatically. This is the biggest advantage of ArrayList over arrays. You can keep adding or removing elements as your application's data changes, without worrying about managing the size yourself. But this raises an interesting question. If we never specify the size, how does ArrayList keep growing behind the scenes? Does Java allocate memory every time we call add? Let's understand the internal working of ArrayList in the next section. First, let's look at initialization. When you type new ArrayList, you might think Java immediately creates an array of 10 slots. But there's a catch: Java is lazy. It actually starts as an empty reference. However, as soon as you add that very first element, the ArrayList initializes its internal array with a default capacity of 10. So, even if you only add one item, it's already prepped that extra space for you in the background. Now, here is the cool part. What happens when you hit that 11th element? You're out of space. Does it crash? No. It triggers an automatic resize. Think of it like this: the ArrayList creates a brand new, larger array, specifically 50% larger than the old one, and then it copies everything from the old array into this new, bigger home. It's a bit of work for the JVM, but that's the cost of having a list that feels like it has infinite space. When you add an element, it's usually super fast, what we call O1 time complexity, because you're just dropping an item at the end of the line. But removing is different. If you remove an element from the middle, the list has to shift every single subsequent element to the left to fill that gap. That's why remove is actually more expensive than add in terms of performance. So, keep this in mind: ArrayList is a wrapper around a standard array. It handles the heavy lifting of resizing and shifting so you don't have to. It's a great balance between the convenience of a dynamic list and the speed of a raw array. Hope that clears up what's actually happening when you run your code. Let's summarize everything. Arrays have a fixed size. ArrayLists grow dynamically. Arrays use the length property. ArrayList uses the size method. Arrays support primitive data types directly. ArrayList stores objects, so primitive values are automatically wrapped into their corresponding wrapper classes. Both provide fast random access, but ArrayList offers many useful collection methods. Deciding between a standard array and an ArrayList doesn't have to be guesswork. Just follow this decision tree. First question: is your data size fixed or dynamic? If you know the exact size from the start and it's never going to change, a standard array is your best friend. Next, look at your needs. Do you need absolute raw performance and direct memory access for primitives? Go with an array. But, if you're like me, building Spring Boot apps where developer productivity and features, like add, remove, or contains, matter more, ArrayList is the clear winner. Think about your scenario. If you're dealing with static configuration data, stick to arrays. But for everything else, like dynamic shopping carts or user profile lists, ArrayList handles all the heavy lifting of shifting and resizing for you. Choose the right tool for the job, and you'll write cleaner, safer code every single time. If you found this video helpful, don't forget to like and subscribe to Spring Java Lab, and I will see you in the next video.